Welcome to ClickMyProject.com.
Now we can going to discuss about the product network restoration in wireless sensor network for next generation application. Next we can going to discuss about the abstract of our product, the proposed system we can implement for the wireless sensor network for the energy restoration. This is a high efficient you can implement the wireless sensor networks, and we can this is a next level of generation we can to the real-time applications also. This development of networks of network restoration model, we can design the two major objectives we can focus on. First objective, we can focus the optimize the network resource utilization, and the second we can product the failure against the nodes. So these two techniques we can mainly focus on our process, and we can realizing of the goal of objective, we can usage of our lifetime network and energy restoration process, and we can ability to remain the active service of the every nodes, and in case node and our connecting links are failed, it will be automatically recovered to that links will be connected from the another link lines. To achieve the second goal, we can leverage of p cycles. The p cycles means we can positive propagation cycles, we can restore of these solutions. The solution we can using the one of the technical types, and we can find out the capacity and the average node method. We can find out these optimal methods we can using that, and we can selective employment of this process of shortest length and the best topologies and capacity requirement we can available to create that p cycles and assuming the new capacity optimal of p solutions and restoration. Next we will going to discuss about the flow diagram of the product. This is a flow diagram of the product, and first we can see about deploy the nodes. We deploy the nodes, we can deploy the random nodes for that our entire some junctions, and we can get rid separate for the clusters, and these each nodes are like clusters, and we can scattering that clusters, and we can the cluster point. The cluster point is nothing but we can point out the node position. We can access of the x and y limit, we can find out this axis position for the cluster point, and we can another method for the shortage length. The shortage length is nothing but we can connecting links where to each other. These links are of how much length we can connect to the each node, and every node we can get connected to them, and sometimes we can interface the links for the inactive nodes. This will be very line will be automatically connected, so the node will be automatically activated, like we can that node some other nodes. So this is shortage for the block, and next you can best topology. This best topology is nothing but we have clusters, a lot of clusters, and we can separate it for the 3 or 5 something. We can segregate the our cluster points. So the cluster points we can segregate it for the we can grouping the links. So this something we can find in our paper using the 3 cluster points for sub networks, so we can connect out to each other. And the next block we can use for the capacity efficiency. In the capacity efficiency we can using the capacity of the node, and the inactive node we can how efficient we can store that energy, and we can network lifetime will be how we can recover that. So these are capacity, energy, performance, and finally we can see about the performance. This is on 4 performance we can find out that, and the first one is on total capacity cost. This is on our entire capacity of the our sensor node networks, so we can find out the total capacity cost. Next move on for to the network lifetime. The network lifetime we can the how node will be activated the how much time, and we can node will be inactive and active nodes are not different to getting, so that to improve our lifetime of the nodes. And the third one will be average path length. In connecting the two nodes, this one difference of length we can connect it to each other, so this path will be can find out that, so we will be calculated as average path length. And another thing we can move for the link failure in nodes. This is a link failure in nodes, like fourth one is a link failure in nodes. This will be some connections of nodes will be automatically disconnected because of our lifetime of our sensor network will be automatically reduced. So sometime we can connecting nodes will be link failure, so this performance we can also find out that. Next we can go to discuss about the running procedure of the product. The proposed system is the implementation done in Matlab version 2015b, and we have a Matlab code for this main file, and this is subfunctions file for different manual functions file. This is using that very large number of sub functions file will be integrated to calling to each others, and this and main program of the code. This code will be integrated like we can initialize the parameter, and some more base station and constellation of nodes something will be find out them. I will run that program model. It will be running now. Wait bar still loading. Will be simple network model for the wireless sensor network for adaptable next generation application for IoTs, and these blue nodes will be active node, red node will be inactive node, and these pink color lines are connecting links to the nodes to integrate to each other nodes to connecting that links. These nodes are communicating to each other, so it will interlink to different types of nodes. And this figure will be P cycle enveloped for link failure restoration in wireless sensor network design for that next generation application. You can see the pink color mark will be general connector link, and you get the P cycle link can connector for that. I think black mark will be connected to different links for the nodes. Now it be black color mark will be started 16 to 15. We can see that this flow will can connected like, and we can see the our line failure also for this figure. This block I think line, this is a line failure, and this figure will be sub network interfacing to each others. These nodes will be connected to interface the inactive node also. And finally see the our every performance plot. First this is wireless sensor for adaptable next generation application for the IoT. You can see that running model of this process, and this is our line failure. This 621 will be line failure of the this model, and this is subnetwork of link to, we can segregate the three separate blocks, like we can segregate the nodes. Just to see that 16 to 16 file lines, and these also we can connect it to them. And this is our capacitance link restoration, and the selection of base link store model. It will be plotted. What is this total capacity is on y axis, and average node degree will be x axis. This is on our capacity cost for that our NEPC model, and we can find out the different ratios for that 0, 0.25, 5, and 0.75. We can segregate it different. This also similar, and but we can using some reference value you can import this file, and this figure we can find out the capacity efficient and topology in numerical methods. These three categories we can find out this comparison plot, and finally we can find out the general link restoration model and the selection of base link restoration model. Because of this blue line will be improved getting that results to restore the models. Finally, thanks for watching.